As we go from left to right, first we hit a 4. So the things we always have to ask ourselves, our first question, is this vertical or is it horizontal? Is it outside the function or is it inside the function? So that 4 is outside the function. That's telling you it's going to do something vertical. Is it going to be a stretch or is it going to be a compression? And if you think about what would you multiply your y values by? Would you multiply them by 4 or would you multiply them by 1/4? When do we do the reciprocal? When do we not? In this case, vertical stuff is just how it looks. We'd multiply by 4. That's telling us, and I'll just use abbreviations here, that that's a vertical stretch. Once we get inside the function, I'll change colors here, we have two things. We have a negative and we have the 0.5. They're both going to be horizontal things. The negative is going to give us our horizontal reflection. And our 0.5, if we think, and we can combine both of these into one thing, that's a half. Multiplying by the reciprocal, we're going to multiply our x values by -2, so this will be a horizontal stretch. If you had to describe what's happening, there's two things to describe, horizontal reflection and horizontal stretch. When we're doing the algebra to our points, there's only one thing you need to do. You can do both that horizontal reflection and the horizontal stretch at the same time by multiplying your x values by -2. So if we look at the graph that we've been given, and we've been given it in function notation, so they've just said this is a function, and here's the function notation afterwards. We can look at some key points on here. Looks like we have -2, 0, -1, 1, and 2, 2. So when we go to show our work, right above this first arrow, we're going to write what we're going to do. We're multiplying our y values by 4, our x values by -2. Where do these points end up? So all my x values by -2, all my y values by 4, and we can start plotting our points. So we're going to have 4, 0, 2, 4, and -4, 8, which would be probably up over there somewhere. And we've got 3 points drawn. Now, what we don't know is once we have those 3 points drawn, how do I connect them? Should I connect them this way and put my arrowhead there, or should I start here and connect them this way and put my arrowhead there? That's the question that we have. Well, to think about that, we can look back at our original graph and say, this is our key point. That's where everything starts. That's -2, 0. Where did that point go? That point changed to 4, 0. So when I'm drawing it, I know that this is my starting point. I'm going to start here, and so I have to go up in this direction. Another thing I'd like you to do after you've got your points and you've drawn your graph is just sort of go through what happened. Does this seem to make sense? Does it look like there's been a vertical stretch? Yeah, I think so. Do I have the horizontal reflection right? That's the key one here. And that's why it's going the other direction, because if you flipped it over the y-axis, it would be going in the other direction. So I would say that your horizontal stretches and vertical stretches aren't always easy to tell if you've done them completely right. You're going to have to trust your points, okay? But you definitely can see if your horizontal reflection is there. And then, is the shape look like the correct shape in the end? Do I have the same kind of curve that I did to begin with? So those are some things that we can do to check. Now, for domain and range of each function, start with our original one. Can you see that your x values start bigger than or equal to 2 and your y values bigger than or equal to 0? And then on our image graph, our domain now, its biggest value is 4, so our x values are less than or equal to 4. Our range is still bigger than or equal to 0. So we can see how that multiplying y by 4, that wouldn't change our inequalities. Multiplying x by a -2, well, that changes your -2 to 4, and it also flips your inequality. That's what that multiplying by a negative will do. And so now it's x is less than or equal to 4. Now this is a good question because what we were given as a starting graph is one of the graphs that we should be able to recognize. In fact, we're going to add maybe a 3.5, or we can call it a part B to this question. Here we'll do question 3.5 right underneath. I'm going to do 2 parts to it. I want you to tell me the explicit equation. So that's not in function notation. For our original graph, which was y equals f of x. That was our red one. What graph is that red one? I'll write the equation in red as well. What would we say f of x is equal to as an explicit equation? It's a square root of x graph, and a square root of x graph hasn't been moved at all. Because we noticed those 3 points, right? That over 1, over 1, over up 1, over 3 seems to match up with our square root graph. But it's not starting at 0, 0. So how do I show that? It's going to be square root. It's not just the square root of x, because there's been a translation. It's going to be plus 2 because it's been moved 2 to the left. Now for part B, I now want you to think about function notation for what we drew in blue. So how do I go from what I know f of x is and use that to figure out 4f of negative 0.5x? Again, whatever's outside the function is just going to stay as you see it. So here I'm going to have 4 times f of negative 0.5x. I'm writing the explicit equation. That 4 is going to stay a 4. And we might even want to put a big set of brackets here, because now we have to replace this f of negative 0.5x with something. We know that f of x is the square root of x plus 2. So if I asked you to do f of 6, you'd plug in 6 for x, right? If I asked you to do f of 20, you'd plug 20 in for x. I'm asking you now to do f of negative 0.5x. The idea stays the same. You just take that negative 0.5x, whatever's inside the function, and replace that where the x was. So our original function had a square root of x plus 2, but instead of writing x, I'm now going to write negative 0.5x plus 2. And this is the explicit equation for the graph that we did in blue. And coming up in period 3 today, we're going to start doing these kind of graphs. The graphs that have stretches, compressions, and translations all combined. Sort of putting everything that we've done so far and say, if you were asked to graph 4 times the square root of, here, now we can remove some brackets and just simplify this nicely. This is going to be 4 times the square root of negative 0.5x plus 2. In period 3, we're going to find out if you were given this equation, how you could start from your regular square root graph and get to the final graph that we had. Okay, questions for practice on this one, 7, 9, and 10.